Hi, hello, this is Giri, teaching 10th Mathematics, the chapter Real Numbers. Introduction to Logarithms and the problems and solutions of exercise 1.5. Here is the introduction to logarithms. First of all, do you know what is logarithms and how it is useful? You see here, if I are given the equation 10 power x is equal to 100, and if you are asked to find the value of x, then how do you proceed? Here, if I are given 10 power x is equal to 100 and if you are asked to find the value of x, then you can write this 100 as 10 square. Then if 10 power x is equal to 10 square means bases are equal. If bases are equal, you can equate the exponents so that x is equal to 2, you may say. Similarly, if I are given 2 power y is equal to 8, and if you are asked to find the value of y, then how do you proceed? Then you may write this 8 as 2 into 2 into 2, that is 2 cube. 2 power y is equal to 2 cube. Here bases are equal so that you can equate the exponents, and you may write y is equal to 3. You can solve these two equations by writing both the RHS to the same base of LHS. But if the questions are like this, for example, if 10 power z is equal to 2, then can you find the value of z by using this knowledge? Here, in order to find out the value of z when 10 power z is equal to 2, you have to write the value of 2 to the base of 10. But 10 power 0, 10 power 1, 10 power 2, 10 cube, 10 power 4, and no value is equal to 2. Therefore, you cannot write 2 to the base of 10. So that you cannot find the value of z by using the above knowledge. Similarly, if you look at the second example, 2 power a is equal to 5. Then can you find the value of a by the previous knowledge? If 2 power a is equal to 5, in order to find out the value of a, you have to write the 5 to the base 2. Means 2 power 1, 2 square, 2 cube, 2 power 4, 2 power 5, and no value of 2 power 1, 2 power 2, 2 power 3 is equal to 5. Therefore, you cannot find the value of a using our previous knowledge. In these above cases, in order to solve these type of equations, we need the knowledge of logarithms. Now, let us know the definition of the logarithms first of all. If a power x is equal to n, and then we can write x is equal to log n to the base a. Logarithms, in shortcut, you may write this as log, L-O-G, log. Log n to the base a. You should read this as x is equal to log n to the base a. Logarithm of n to the base a. In shortcut, you can write it as log n to the base a. Here the condition is a should be greater than 0. Means base should be greater than 0, and a is not equal to 1, and n is greater than 0, and both a and n should be real numbers. I shall repeat the definition. If a power x is equal to n, then you can write x is equal to log n to the base a, where a is greater than 0 and a is not equal to 1, and n is greater than 0, and both a and n should be real numbers. In this case only, you see here a power x is equal to n. This is an equation in exponential form. And whereas x is equal to log n to the base a, it is in another equation. This equation is in logarithmic form, you can say. Here a power x is equal to n is called an equation in exponential form, and x is equal to log n to the base a is called an equation in logarithmic form. Therefore, a power x is equal to n can be written as x is equal to log n to the base a. Now let us see one or two examples. For example, if 10 power z is equal to 2, that is what we thought of previously. 10 power z is equal to 2. If 10 power z is equal to 2, you could not find the value of z using our previous knowledge. But by using logarithms, if 10 power z is equal to 2 is the given equation, then you can say that the value of z is equal to log 2 to the base 10. You see here, if a power x is equal to n, means 10 power z is equal to 2. Our given equation 10 power z is equal to 2 is in the form of a power x is equal to n, where a is equal to 10, x is equal to z and n is equal to 2. If the given equation is in the form of a power x is equal to n, then you can find the value of x as log n to the base a. Therefore, here also the value of z is equal to log 2 to the base 10. Here, if 10 power z is equal to 2, then from the definition of the logarithms, you can find the value of z as log 2 to the base 10. As there is a value for log 2, so that you can find the value of z. There are logarithmic tables, and using the logarithmic tables, you can find the value of z. And look at the second example. The second example we thought of previously is 2 power a is equal to 5. If 2 power a is equal to 5, then you could not find the value of a using our previous knowledge. But here, from the definition of logarithms, you can write the value of a as log 5 to the base 2. Again, you can find the value of log 5 to the base 2 from logarithmic tables, and those tables are developed by John Napier. You can find the value of log 5 to the base 2 from the logarithmic tables. Now the next concept is I have to change the exponential form to logarithmic form and vice versa, that is logarithmic form to exponential form. Let us convert the given equations into logarithmic form to exponential form and exponential form to logarithmic form. Let us know one or two examples. Here from the definition we know that if a power x is equal to n, then log n to the base a is equal to x. Here if a power x is equal to n, then log n to the base a is equal to x. Here if you observe both, then how do you remember this? Here the base is a. In exponential form a power x is equal to n. Here the base is a. Here also the base is same a. Therefore, if a power x is equal to n, this is the exponential form. If you are asked to write this exponential form into logarithmic form, then you can write the same equation as log n to the base a is equal to x. Or you can change the logarithmic form to exponential form also. That is, if log n to the base a is equal to x, then you can write the same equation in exponential form as a power x is equal to n. For example, you see here, if 10 square is equal to 100, 10 square is equal to 100. This is in the exponential form. Now let us convert this into logarithmic form. If you write it in logarithmic form, then 10 square into 100 may become log 100 to the base 10 is equal to 2. The value of log 100 to the base 10 is equal to 2. This is how we have to convert the exponential form equation into a logarithmic form. Let us see another example. If log 8 to the base 2 is equal to 3, this equation is in logarithmic form. And let us convert into exponential form as the base is 2. Therefore, 2 cube is equal to 8. This is the equation in exponential form. You may repeat the same video if you have any doubts, so that you can understand the usage of logarithms, you can know the definition, and you may understand how to convert exponential form into logarithmic form and vice versa. Now let us know some laws of logarithms here. The first law is log xy to the base a is equal to log x to the base a plus log y to the base a. For example, if I have given log 15, then this 15 can be written as 3 times of 5, that is 3 into 5. Log 3 into 5, this is in the same model, log x into y, which is equal to log 3 plus log 5. Similarly, another example, log 2 plus log 3 plus log 5. Here, this is in expanded form. Now, if you simplify this, then you can write the same as log of, since plus is there, you have to multiply 2 into 3 into 5. 2 into 3 is 6, 6 into 5 is 30. Therefore, in simplified form, log 2 plus log 3 plus log 5 is equal to log 30. In both the examples, we used the same log, which is log xy to the base a is equal to log x to the base a plus log y to the base a. And second law of logarithms is log x divided by y is equal to log x to the base a minus log y to the base a. Here is an example, log 3 by 2. 3 divided by 2 means it is log 3 minus log 2. It is an expanded form. Similarly, another example, log 100 minus log 50. If you are asked to simplify this, then you can write the same as log of 100 by 50. Why? Since this is in the form of log x minus log y. Log x minus log y is equal to log x divided by y. That is log 100 divided by 50, which is equal to log 2. Since 50 in 100 2 times. Now look at third law. Log a power n is equal to n log a. For example, log 25. You can write 25 as 5 square. Here this exponent may come as quotient, that is 2 into log 5. Therefore log 25 is nothing but 2 into log 5 by using the third law. Log a power n is equal to n log a. Another example, 4 log 3. If we are asked to take this 4 inside, then log 3 power 4. 3 power 4 means 3 into 3 into 3 into 3, which is equal to log 81. And the fourth law of logarithms, log a to the base a is 1. Log a to the base a is equal to 1. For example, you see here, 2 log 3 to the base 9. How can we simplify this? Here if you apply the third law first of all, this is in the form of n log a. Therefore take this 2 inside. So that this is log 3 square to the base 9. What is 3 square? 3 square is 9. Therefore log 9 to the base 9. Now if we apply the fourth law now, log a to the base a is 1. Therefore log 9 to the base 9 is 1. And another example, log 0.001 to the base 10. You can write this 0.001 as log 10 power minus 3 to the base 10. 10 power minus 3 is nothing but minus 3 log 10 to the base 10, and whose simplified value is minus 3. Here it is not mentioned there, but you may please note down that log 10 power minus 3 to the base 10 is minus 3 log 10 to the base 10, which is equal to minus 3. You can complete this. And fifth law, a power log n to the base a is equal to n. A power log n to the base a is equal to n. Here is an example, a power log 3 to the base a, whose value is 3. If you find any type of such equations, you can use all these laws of logarithms so that you can simplify the given equations in logarithms. Now let us go to exercise 1.5 of the chapter real numbers. Exercise 1.5. Here is the first question. Determine the values of the following: log 5 to the base 25, log 3 to the base 81, log 1 by 16 to the base 2, and 8th bit log 8 by 27 to the base 2 by 3, and 9th bit 2 power 2 plus log 3 to the base 2. I shall repeat. Determine the values of the following: log 5 to the base 25, second bit log 3 to the base 81, third bit log 1 by 16 to the base 2, and 8th bit log 8 by 27 to the base 2 by 3, and 9th bit 2 power 2 plus log 3 to the base 2. Now let us see the solution. Here is the solution now. The first bit is, we have to find the value of log 5 to the base 25. Log 5 to the base 25. Here, this 25 can be written as 5 square. You cannot change 5, therefore write the 5 as it is. But this 25 can be written as 5 square. Log 5 to the base 5 square. This is in the form of log a to the base a power m. Log a to the base a power m. Whose value is 1 by m log a to the base a. If we apply this law, then you can write this as 1 by 2 log 5 to the base 5. But you know that log 5 to the base 5 value is 1, as log a to the base a is equal to 1. Therefore, this is 1 by 2 into 1 is 1 by 2. And the simplified value of log 5 to the base 25 is 1 by 2. And let us see the second bit now. Log 3. What is the second bit? Log 3 to the base 81. Log 3 to the base 81. Now let us prime factorize 81. 81 is nothing but 3 power 4. Therefore, this is log 3 to the base 3 power 4. Again, this is in the same model of log a to the base a power m. His formula is 1 by m log a to the base a. Therefore, this is 1 by 4 log 3 to the base 3. But log 3 to the base 3 value is 1, as log a to the base a is equal to 1. Therefore, this is 1 by 4 into 1 is 1 by 4. And let us solve the third bit now. Here is the same question we have, and let us solve third bit. Log 1 by 16, you see the third bit. Log 1 by 16 to the base 2. Log 1 by 16 to the base 2. You can write 16 as 2 power 4. Log 1 by 2 power 4 to the base 2. 1 by 2 power 4 is equal to 2 power minus 4. From laws of exponents, 1 by a power n is equal to a power minus n. Therefore, this is log 2 power minus 4 to the base 2. Now, this exponent may come as quotient. That is, minus 4 log 2 to the base 2. Why? Because this is the formula. Log a power m to the base a is equal to m into log a to the base a. Therefore, this is minus 4 into log 2 to the base 2. But log 2 to the base 2 value is 1. Therefore, this is minus 4. And now, 8th bit. Log 8 by 27 to the base 2 by 3. 8 is 2 cube and 27 is 3 cube. Therefore, 8 by 27 is 2 cube by 3 cube or 2 by 3 whole cube. Therefore, log 8 by 27 to the base 2 by 3 is log 2 by 3 whole cube to the base 2 by 3. In the same model you can apply. That is, log a power m is m log a to the base a. Therefore, you write this exponent as quotient, that is 3 into log 2 by 3 to the base 2 by 3. Log 2 by 3 to the base 2 by 3 value is 1. Therefore, this is 3 into 1 is equal to 3. And now, 9th bit. 2 power 2 plus log 3 to the base 2. 2 power 2 plus log 3 to the base 2. Here, this is in the form of a power m plus n. A power m plus n is a power m into a power n. This is from laws of exponents. A power m plus n is a power m into a power n. That is 2 square into 2 power log 3 to the base 2. 2 square is 4. This is in the form of law of logarithms, where a power log n to the base a is equal to n. You can straight away apply this law so that 2 power log 3 to the base 2 value is 3. 2 square is 4 and this value is 3 and 4 into 3 is 12. Now look at question number 2. Write the following expressions as log n and find their values. The first bit is log 2 plus log 5. Second bit is log 16 to the base 2 minus log 2 to the base 2. And fifth bit is log 10 plus 2 log 3 minus log 2. I shall repeat. Write the following expressions as log n and find their values. First bit is log 2 plus log 5. Second bit log 16 to the base 2 minus log 2 to the base 2. And fifth bit is log 10 plus 2 log 3 minus log 2. Here is the solution. The first bit, you can say the first bit now. The first bit is log 2 plus log 5. Here, I have to write this in simplified form. We have to write the log 2 plus log 5 in a simplified form like log n. Means you have to write it into a single and simplified form. Look at the first bit. Log 2 plus log 5 is equal to. This is in the form of log m plus log n. Log m plus log n is log m into n, or log x plus log y is log xy. Therefore, this is log 2 into 5. What is log 2 into 5? 2 into 5 is 10. Therefore, the simplified form of log 2 plus log 5 is equal to log 10. And now look at second bit. Log 16 to the base 2 minus log 2 to the base 2. Here minus is there, which is in the form of log m minus log n, or log x minus log y, which is equal to log m divided by n. Therefore, this is log 16 divided by 2 to the base 2. Log 16 divided by 2 to the base 2. What is 16 divided by 2? 16 divided by 2 is 8. Log 8 to the base 2. But you can write 8 as 2 cube. Log 2 cube to the base 2. Now, this exponent, log 2 cube to the base 2, you can write it as 3 log 2 to the base 2. How? Because log a power n is equal to n log a. Therefore, this is 3 log 2 to the base 2. Again, you can simplify this. As log 2 to the base 2 value is 1, therefore, this is 3 into 1. 3 into 1 is 3. And look at fifth bit now. Log 10 plus 2 log 3 minus log 2. Log 10 to the base 10 plus 2 log 3 minus log 2. Here, this 2 is multiplying log 3. If we take it inside, it should become the exponent to 3. Therefore, this is log 10 plus log 3 square minus log 2. Why? Because n log a is equal to log a power n. Now, plus is there in between these two terms and minus is there in between these two terms. Therefore, since it is plus, these two should be multiplied. Since minus is there, we have to divide this 10 and 3 square with 2. That is log 10 into 3 square means 9 divided by 2. Log m plus log n is log m into n, and log m minus log n is log m by n. So that this is log 10 into 9 divided by 2. Now, log 10 into 9 is 90 divided by 2 is log 45. Now, question number 3. Here is the question number 3. Evaluate each of the following in terms of x and y if it is given that x is equal to log 3 to the base 2 and y is equal to log 5 to the base 2. The first bit is log 15 to the base 2, and second bit is log 7.5 to the base 2, and fourth bit is log 6750 to the base 2. I shall repeat. Evaluate each of the following in terms of x and y if it is given that x is equal to log 3 to the base 2 and y is equal to log 5 to the base 2. The first bit log 15 to the base 2, and second bit log 7.5 to the base 2, and fourth bit log 6750 to the base 2. Here is the solution. Now, before going to the solution, what is given in the question? We have given that x is equal to log 3 to the base 2 and y is equal to log 5 to the base 2. Let us mention that. Given x is equal to log 3 to the base 2 and y is equal to log 5 to the base 2. Now go to the first bit, log 15 to the base 2. 15. If you write it 15 as product of two prime numbers, you can write this as log 3 into 5 to the base 2. This is in the form of log x into y. Log x into y is nothing but log x plus log y. Therefore, this is log 3 plus log 5. What is log 3 to the base 2? Log 3 to the base 2 is x. And what is log 5 to the base 2? Log 5 to the base 2 is y. Therefore, let us substitute the values of x and y in the place of log 3 to the base 2 and log 5 to the base 2. If you substitute, then log 15 to the base 2 is log 3 to the base 2 plus log 5 to the base 2, which is equal to x plus y. Log 7.5 to the base 2. You can write this decimal number into a fraction. It is log 75 by 10 to the base 2. Now let us simplify this. You can cancel 5 in both numerator and denominator. 5 in 75 15 times and 5 in 10 2 times. Therefore, this is log 15 by 2 to the base 2. This is in the form of log x by y. Log x by y is equal to log x minus log y. log 15 by 2 is equal to log 15 minus log 2 if we apply this formula. Now you can write 15 as 3 times of 5, and log 2 to the base 2 is same as it is. Now log 15 is log 3 into 5 to the base 2 minus log 2 to the base 2. Now this is in the form of log x into y. Log 3 into 5 is log x into y. Log x into y is log x plus log y. Therefore log 3 into 5 is log 3 plus log 5 minus log 2 to the base 2. But we know that log a to the base a is 1. Log a to the base a is 1. Therefore log 2 to the base 2 is 1. And log 3 to the base 2. Log 3 to the base 2 value is x. Therefore this is x. And log 5 to the base 2 value is y, therefore this is y, and this is minus 1. Therefore, finally you wrote 7.5 to the base 2 as x plus y minus 1. And now look at fourth bit, log 6750 to the base 2. Log 6750 to the base 2. First of all, let us convert 6750 into prime factors. As 0 is there in its place, it can be divisible by 2. Therefore, this is 2 into 6. 2 in 6 3 times, 2 in 7 3 times, 2 in 15 7 times, 2 in 10 5 times. Now, the sum of all the digits is 3 plus 3 is 6, 6 plus 7 13, 13 plus 5 is 15. Therefore, this is divisible by 3. 2 into 3 into 3 in 3 1 time, 3 in 3 1 time, 3 in 7 2 times, and 3 in 15 5 times. And again it is divisible by 3. 2 into 3 into 3 into 11, 3 in 11 3 times, 3 in 22 7 times, 3 in 15 5 times. Again it is divided by 3. Therefore this is 3 into 125. This 125 can be written as 5 into 5 into 5. Therefore, finally, 6750 prime factorization, you can write this as 2 into 3 cube into 5 cube. Log 6750 to the base 2 is equal to log 2 into 3 cube into 5 cube to the base 2, which is in the form of log x into y into z. Log x into y into z is nothing but log x plus log y plus log z in expanded form. Therefore, let us expand this. Log 2 to the base 2 plus log 3 cube to the base 2 plus log 5 cube to the base 2. Log 2 to the base 2 plus, now this is in the form of log a power m to the base a. Log a power m to the base a is equal to m log a to the base a. That is, this exponent may become quotient. That is 3 log 3 to the base 2. This is also in the same model. Log 5 cube to the base 2 is nothing but 3 log 5 to the base 2. Now log 2 to the base 2 value is 1, therefore this is 1, plus 3 into log 3 to the base 2 is x. From the given log 3 to the base 2 is x, therefore this is 3 times of x, plus 3 times of log 5 to the base 2. But log 5 to the base 2 is y, therefore this is 3 times of y. Finally, log 6750 to the base 2 can be written as 1 plus 3x plus 3y. If x square plus y square is equal to 25xy, then prove that 2 log x plus y is equal to 3 log 3 plus log x plus log y. I shall repeat the question. If x square plus y square is equal to 25xy, then prove that 2 log x plus y is equal to 3 log 3 plus log x plus log y. Now let us see the solution now. Here in the given question we have given x square plus y square is 25xy. Let us add 2xy on both sides. Why? Because LHS is in the form of a square plus b square. If 2ab term is also there, then you can write it in the form of x plus y whole square. Further, let us add 2xy on both sides. LHS plus 2xy is equal to RHS plus 2xy. LHS means x square plus y square plus 2xy is equal to RHS means 25xy plus 2xy. hold this in the form of a square plus b square plus 2ab, which is a plus b whole square, that is x plus y whole square is equal to 25xy plus 2xy, 25 plus 2, 27xy. Now if we write 27 in exponential form, this is 3 cube, 3 into 3 into 3 is 27, therefore 3 cube xy. Now let us apply logarithms on both sides. Why? Because we have to prove that 2 log x plus y is equal to 3 log 3 plus log x plus log y. Therefore, let us apply logarithms on both sides. Then log of LHS is equal to log of RHS. Now, here this is in the form of log m to the power n is n log m. That is, these two may come as quotient. That is, 2 log x plus y is equal to log 3 cube xy. This is in the form of log mn, log m plus log n. Here we have 3 values. Therefore, log 3 cube plus log x plus log y. Now, this log 3 cube is in the form of log m power n, that is n log m. Therefore, 2 log x plus y is equal to, this 3 will be quotient, 3 log 3 plus log x plus log y. Now, let us see another question. If log x plus y by 3 is equal to half of log x plus log y, then find the value of x by y plus y by x. I shall repeat. If log x plus y by 3 is equal to half of log x plus log y, then find the value of x by y plus y by x. This is the solution. Given log x plus y by 3 is equal to half of log x plus log y. LHS log x plus y by 3 is equal to half of log x plus log y. This log x plus log y is in the form of log m plus log n. Log m plus log n is log mn, that is log xy. This 1 by 2 is the quotient. If we take it inside, then it will become exponent, that is log xy to the power 1 by 2. Xy to the power 1 by 2 is nothing but square root, log root over xy. LHS is log x plus y by 3 and RHS is log root xy. Now let us remove logarithms on both sides. Why? Because there is no logarithms in the conclusion. Therefore, if we remove this logarithm, x plus y by 3 is LHS. If we remove this logarithm, root xy is RHS. By squaring on both sides, in order to remove this square root, let us square on both sides. Then LHS whole square, x plus y by 3 whole square is equal to root over xy whole square. Or take this 3 to the other side, then x plus y whole square is equal to 3 root xy whole square. That is a plus b whole square, a square plus b square plus 2ab, x square plus y square plus 2xy is equal to 3 square is 9, root xy whole square is xy. Take this plus 2xy to the other side, then x square plus y square is equal to 9xy minus 2xy. 9 minus 2 is 7xy. Now let us divide this equation with xy. That is x square by xy plus y square by xy is equal to 7xy by xy. Now this x in x square x times, that is x by y, plus this y in y square y times y by x is equal to 7xy by xy will be cancelled, will get 7. Therefore, x by y plus y by x is equal to 7. And we will see another question. If 2.3 whole power x is equal to 0.23 whole power y is equal to 1000, then find the value of 1 by x minus 1 by y. I shall repeat. If 2.3 whole power x is equal to 0.23 whole power y is equal to 1000, then find the value of 1 by x minus 1 by y. This is the solution. Here we have given 3 values are equal. Now let us equate first and last first of all. That is 2.3 whole power x is equal to 1000. If you write this in a logarithmic form, log 1000 to the base 2.3 is equal to x. But we need the value of 1 by x. Therefore, let us find the reciprocal of this logarithm. Reciprocal of a logarithm is nothing but you have to interchange these two values. That is, log 2.3 to the base 1000 is equal to 1 by x. Similarly, on the other side, 0.23 whole power y is equal to 1000. By writing this exponential form into logarithmic form, log 1000 to the base 0.23 is equal to y. Again, we have to find 1 by y. That is, log 0.23 to the base 1000 is equal to 1 by y. Now, let us find the value of 1 by x minus 1 by y. 1 by x minus 1 by y is equal to 1 by x value log 2.3 to the base 1000 minus 1 by y value log 0.23 to the base 1000. This RHS is in the form of log m minus log n. Log m minus log n is log m by n. That is log 2.3 by 0.23 to the base 1000. This is equal to log this 0.23 and 2.3 10 times. That is log 10 to the base 1000. That is log 10 to the base 1000 means 10 cube. This is in the form of log a to the base a power n. Log a to the base a power n is 1 by n. Therefore, this will be 1 by 3. 1 by x minus 1 by y is equal to 1 by 3. Thank you. Thank you. Thank you, one and all.